Hello. So welcome in the lecture of epicycloid. So epicycloid is just familiar to cycloid as we have already drawn cycloid. So first of all I am giving you the definition of epicycloid. So what is epicycloid? Now by the means of this diagram I have to explain epicycloid. See, suppose there is a circular path and a circle is rolling over this circular path for one complete revolution. We take here one complete revolution. So a point on the circumference of rolling circle make a curve is called epicycloid. Okay, so this circle is called rolling circle and this circle is called directing circle. So in question they generally radius of rolling circle and radius of directing circle is given and we have to draw epicycloid. So some basic construction I have already drawn. This I am going to explain. First of all, we take a point O and by taking this center we draw at a radius 75 mm, that is radius of directing circle. Draw a circular path. No need to draw this completely. Okay. Now at this point we have to draw another circle. This is radius of rolling circle, that is 25 mm. So for construction point of view, from this center we join a line and then extend it and take radius r here, small r here, and draw a circle simply. Okay, so this is basic construction. And one more construction where it completes is 2 pi r, means one revolution. For that we calculate theta. This theta is equal to 360 into small r upon capital R, and if we calculate this we get this 120 degree. So we make an angle of 120 degree here, and here we ends our curve. So I am going to start. The construction is almost about same, that is of with cycloid. You can compare this construction with a cycloid. Now divide this circle into 12 equal parts as usually. You know the construction of dividing a circle into 12 equal parts. So that I am not showing here. I just complete 12 parts. So as we divide circle into 12 equal parts in cycloid, the same way we divide this circle into 12 equal parts. Okay. Now if we divide this circle into 12 equal parts, we have to divide this path also in 12 equal parts. So we have angle 120 degree. So either we divide this 120 degree into 12 equal parts, that is 10 degree, and mark 10 degree points here. Otherwise another method is we divide this 120 degree into 4 equal parts, that is 30 degree, 60 degree, 90 degree and 120 degree, and then by trial and error method we can divide this into 3 equal parts. Okay, so whatever method you want to use, you can use for dividing this curve path into 12 equal parts. So now we named here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. And obviously this point is our point P. So this point is our point P dash. And this is the center of the circle, rolling circle. That point we marked as C. Just in cycloid, same in cycloid. Okay. Now next, in cycloid, if you know, this curved path is a straight line and all straight lines should drawn from these points, means parallel to this path. So parallel to this path we have to draw the curved path through 1, 2, 3, 4 and 5. First I have shown you the curved path through C. So see here, what is the path of center? See, this is the path of center. Taking OS center and radius equal to OC. Radius equal to OC and draw an arc parallel to this arc. Draw an arc parallel to this arc. Now through C, means the different centers we have to find here on this line. Okay. Now just like this, you can draw 1, 2, 3, 4 all curved paths. But before that, we find C1 and I will show you how we find C1. Now see here, if we join O, this O to this point is our 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash and 11 dash. Now if we join O to 1 dash, O to 1 dash, O to 1 dash and extend, see here, and extend. If we extend this line, this gives us a point C1. This gives us a point C1. Okay. Now by taking this distance, you can mark C2, C3, C4, C5, C6, C7, or you can extend these lines and get C1, C2, C3, C4, C5 here. Okay. I am going to directly mark C1, C2, C3, C4, C5. So this is give us C6. This gives us C5. This gives us C4, C3 and C2. Just like this, we get all centers. It is necessary C7, C8, C9, C10, C11, C11, and this point is C dash. We can extend this line also. Okay. Now I am going to draw the all curved paths through 1 dash, 1, 2, 3, 4, 5, 6. And remember that center is always O. Center is always O. Now taking O as center and radius equal to O1, we draw one path. Center O, radius equal to O2, we draw another path. and like this we draw all curved path. Taking O as center, and radius equal to O1. Now see here, this curve starts from 11. This curve starts from 11. So, but we draw from through 1. Draw this curved path. Okay. Next, center is O and radius equal to O2. Draw this curved path. Now see, we get point in this side also. So we have to draw this path, this side also. This side also. Okay. Now see, this is the curved path through C, and there is different path through 3 and 9. So remember this thing, that through 3 we have another curved path which is different from C, just little above C path. See here, the path through C and path through 3 and 9 is little different. So please taking care of this. Then through 4, same center O, we have to draw another curved path. Then through same center O, draw another curved path through P. Through same center and through 6. This is our last path, curved path through 6. On this path, we get our center point, that is 6. C6 and P6. So above 6 dash we have C6, and above this we have our point P6, as you know in cycloid. Okay. Now after drawing this curved path, now we have to mark the points. Now as you know in cycloid, the distance of C to P is always small r, that is 25 mm. The distance from C to P, so it will be maintained throughout the curve. So I am going to draw these last points. Now see carefully. First, from here I show you. Now see, the distance from C to P is small r, taking in your compass, and center C1 intersect one arc here. Center C2 intersect one arc here. Center C3 intersect one arc here. Now here taking care that don't intersect on this curve path, because this curve path is through center C, not through center, now not through 3. Now go forward. C4 is center and same radius. Radius is CP. Again I am taking CP. Now see, radius CP, center C4, and mark a point here. Then C5, then C6, C6 curve is like this. C7, C8, C9. Now again taking care. C9 is on this upper curve. C10 and lastly C11. C11. Okay. So I marked here clearly points. This is our first point. This is our second point. This is our third point. This is our fourth point. This is fifth, sixth, seventh, eighth, ninth, 10th, and lastly 11. This is 11, not here. This is here on 11. Okay. So we can give the name of these points P1, P2, P3, P4, P5, P6, P7, P8, P9, P10 like this. Now I am going to draw the final curve, that is epicycloid. Now see, either start from here or start from there. From anywhere you can start. See, this is your final curve. This is your final curve. More slightly darken I have drawn, that show clearly epicycloid. This is our epicycloid. So remember the definition of epicycloid, that is a rolling circle is rolls along the circumference of directing circle. Diameter of directing circle is given and diameter or radius of rolling circle is also given. Okay. So this is our epicycloid. Now we will meet in next lecture. Okay, bye.